Welcome back to your first video about distributions. For this video, our goals are to classify a data distribution as uniform, normal, skewed left, or skewed right, and also to describe the relationship between the mean and median in a data set. Before we get started, I want to remind you how to create a histogram for different pieces of data. So because we already have our histogram here, we know what our numbers are, the categories. So we're going to have 0 to 4, 5 to 9, 10 to 14, and 15 to 19. And for these, I'm going to tally to get my frequency. So 0 to 4. I have a 4, there's 1. There's only one number in that range. 5 to 9, 1, 2, 3, 4, 5. Okay. 10 to 14, 1, 2, 3, 4, 5, 6. And then 15 to 19 should be everything left. 1, 2, 3. So on my histogram, my first section is going to go up to 1. Second section is going to go up to 5. Remember that with a histogram, the bars do connect. 10 to 14, they're going to go up to 6. So that's my highest. And then 15 to 19 just go up to 3. Okay. So looking at these different graphs here, we can decide how the distribution looks based on how everything is arranged. So a set of data collected to answer a statistical question has a distribution, and those are the 4 categories below. A distribution is just how it's arranged, and it shows how frequently the values have occurred. You can describe the distribution by its center, so like the middle, how spread out it is, and the shape, which is what we're looking at today. This can be with a line plot or a histogram. So based on the shape, you can either classify as normal, so the center is right in the middle, and to the left it goes down and to the right it goes down. Uniform means that everything is the same. Notice too, down here at the very bottom, it's kind of hard to see. Let me see if I can scoot my camera area down a little bit. Okay. You can see that in a normal data, it kind of looks like a bell. The mean and the median are likely very close to each other, right in the middle. Same for uniform, okay? But when it comes to having data that is not normal or not uniform, it's called being skewed. Skewed means it either tails down to the left or tails down to the right. And the side that it tails down to is the direction that it's skewed. So if it's skewed left, it drags to the left. If it's skewed right, it drags to the right. And what that means is if it's skewed left, the median is going to be greater. The mean is going to be brought down by these lower values. If it's skewed right, the mean is going to be greater because the mean is brought up by these values that are skewed to the right. Okay? So here's practice problem 1. What can you conclude about the mean and the median of the data represented by the histogram? So look at our categories. Again, we have normal, uniform, skewed left, skewed right. What does this look like to you? okay? It's not perfect, but it definitely is pretty normal, okay? The middle is the highest point, and it drops to the left and it drops to the right. Remember that when our data value is normal, the mean and the median are very close to one another. Therefore, this is the correct answer down here. The mean is about the same as the median. Practice problem 2, what term best describes the shape below? What can you conclude about the mean and the median? So this right here, okay, it tails down to the right, so it is skewed right. Remember, that means that the mean is going to be greater than the median, okay? Because the values that are down to the right are higher, which means it's going to bring up your average. This one, I know it kind of looks a little odd, but it goes down on each end, and the middle is the highest point. So this is your normal. Remember, that means that the mean equals the median. This one, it drags down to the left, skewed left. And remember, that means that the mean is less than the median. The median's greater when it's skewed to the left. So before you leave, make sure you can classify a data distribution as uniform, normal, skewed left, or skewed right, and also be able to describe the relationship between the mean and the median in that data set. Thanks for watching.